So first read the question through very carefully, and then you notice that I made two little notations down here. And so I just want you to recognize that R of t is the rate of dirt that comes in between 0 and 10, and then C of t is the rate of dirt that comes in after time 10, because at time 0 to time 10 they're using a truck, and then after that they're using a conveyor belt. So there is a slight difference there. All right, so now if you go and you read part A, it says to find the best approximation for R prime of 8. Now that right there, you have to start to think, oh, mean value theorem. R prime of 8, that would be the mean value theorem. So then you're just going to do R prime of 8 equals. Now 8 is right here in between the 10 and the 6, so I'm going to use those values. So that would be R of 10 minus R of 6. Oh my goodness, my pen does not want to work, sorry. Over 10 minus 6. And then you just work this out. So you can go into the chart, find R of 10, find R of 6, and see what you get. All right, so then R prime of 8 equals 20 cubic yards per day squared. Now, please remember, what you have here is your R of t is already in a rate, so cubic yards per day. So when you want to actually take the derivative of this already existing rate, you need to always take your unit of time and square that unit of time. Okay, so that's why it's per day squared. Similar to part A, on part B is they're asking, is there guaranteed to be a value of k on the interval from 0 to 10? So they're giving you an interval, and again they're also giving you R prime of k. So this also smells of mean value theorem, and they want to know, does mean value theorem work? And here would be your explanation. So let me just kind of go through it with you. Mean value theorem only works when a function is continuous and differentiable. Now we've talked about that. Okay, so the only way we can use mean value theorem is if we have a function that's continuous and differentiable. They're talking about the function r, and if you go up here and you read this, nowhere here does it say that r is continuous or differentiable. Now, if they told you that r was differentiable, then remember, if a function's differentiable, that implies that it has to be continuous. Okay, but if a function's continuous, that doesn't necessarily apply that the function will be differentiable. So I'm going to say it one more time. If something's differentiable, it's continuous. If something's continuous, it's not necessarily differentiable. Okay, but because they didn't say either in this entire question up here, we don't know if it's differentiable, so we can't apply the mean value theorem. Okay, so first they want you to explain what this integral means. Now, look at what they're integrating. They're integrating R of t, and remember, R of t is the rate that dirt is coming in on that truck. So if they are integrating a rate, what does that give you? And this would be your explanation. So it represents the amount of dirt. It's an amount because you're integrating a rate that comes in on the truck, because R of t represents dirt coming in on the truck from time 0 to time 10, and from time 0 to time 10 strictly because those are your bounds here. Okay, and in cubic yards. We're getting rid of the rate once we integrate. Okay, so then let's look at the next part. So then the next part says use a right Riemann sum with 4 subintervals. So 4 subintervals, so I'm going to have 1, 2, 3, and 4. All right, so we're going to use 4 subintervals, right Riemann sum. So the first interval that I have is going to have a width of 2. The second one will have a width of 3. Then we've got a width of 1. And then we've got a width of 4. I'm going to do one at a time, but just so we know. So we've got 2, and we're going to multiply that times something. Let me just write this. We're going to have 3. We're going to multiply that by something. Then we're going to have 1. We're going to multiply that by something. And then we're going to have 4, and we're going to multiply that by something. Okay, let's talk about the somethings. They said write Riemann sum. So our first interval here, 2 is the number on the right. So we go to its y value, which should be 420. So that's what's going in here, 420. Then we go to the next grouping right here. 5 is the value that's on the right of that interval. The y value that corresponds with that is 510. So 510 goes in here, and so on. So 5 and 6, the next value would be 320. And the last one would be 400. Okay, add it all up, see what you end up getting. And there's your answer, 4,290. Don't forget you need to write cubic yards. Okay, it's an amount, so you're not going to have a rate anymore. Now, just FYI, if this was on your AP, you really don't need to multiply and add everything up. You could just have all of this, and then at the end, right in here, write cubic yards, and that would be totally sufficient. So that's perfectly acceptable. So similar to the last question, here would be your explanation. Just make sure you say that it's an amount, and it is cubic yards, but make sure you also make note that it's the conveyor belt that's bringing the dirt to the location, because we're going from time 10 to time 14. So that would be the conveyor belt at that point. The second part asks you to do a trapezoidal sum with 4 subintervals of equal length. And we're going from 10 to 14. Well, they did give you what C of T's equation was. So what I did down here, now they want 4 subintervals. So look at what I did. I broke 10 to 14 down in units of like a difference of 1. So 10 to 11, then 11 to 12, then 12 to 13, then 13 to 14. So I've got 1, 2, 3, 4 subintervals. Okay, then the next thing I did was I just went up here and I looked at the equation, and all I did was I wrote that in here. I'll explain what I'm going to do. The rest really isn't that bad. So let's think about trapezoidal rule. So trapezoidal rule is, well, area of a trapezoid is 1/2 the height. Okay, now the height for every single one of these is going to be 1, because the distance from here to here is 1. The distance from here to here is 1. The distance from 12 to 13 is 1. And the distance from 13 to 14 is 1. On part C, these distances were not equivalent. So like this distance was 2. This distance was 3. Okay, so that was a little bit different, but I can split 10 to 14 up into 4 equal subintervals, each of them having a height that's equivalent to 1. Now, you don't have to write the 1, but I'm going to show you. All right, now, then basically, after we do 1/2 height, remember we do base 1 plus base 2. Well, the way we find base 1 plus base 2 is to just plug in this 10 into here and get an answer, and plug in 11 into here and get an answer. I'm going to do the upper minus the lower. So for example, if I put in 11 in here, I'm going to get 400 over 2 and 400 over 2. Okay, you do the math on that one. Oops, my pen's not on. That would be 200, right? So then that would be one of my bases. So one of my bases is 200, and then we're going to add the other base to it. So the other base would be putting in 10 down here. So 10 minus 9 is 1, and 400 over 1 is 400. So then I have 200 plus 400. Okay, let's go to the next one. Now, the next one, we're going to put in 11. Doesn't matter what order we do these in, by the way. So if I put in 11 here, well, I already did this before. There's my answer right there. It's 200, isn't it? I think I put these guys backwards. I'm sorry. Well, not that it really matters. So if I put in 11, I get 200 plus. Now, let's see what happens if I put in 12. So if I put in 12 down here, 12 minus 9 is 3, right? And 3 divided into 400 is not going to be pretty, but that's okay. So that's going to be 133.5 0.3 repeating. Alrighty? Plus, well, if I just put 12 in here and got that ugly nastiness, when I put in 12 in here, I'm going to get that same ugly nastiness again, right? I'm going to have to write it on the next line down just because I don't want it to be smushy and ugly looking. So that's going to be 133.3 repeating plus, and now let's put 13 in. So we're going to put 13 in here, 13 minus 9. Okay, so do that, that's 4, and then 4 into 400 is 100, right? So I'm going to have 100 here, which then means in the next one, I'm also going to have 100. And then lastly, I'm going to put 14 in. And take my word on that, when I put 14 in, I end up getting 80. And then just add this all up. Okay, now, let me just explain that once you add all of these numbers inside the bracket up, don't forget you have to cut it in half because the formula is 1/2. All right, all is said and done. Final answer should be 673.3 repeating. Now, if it was an AP, I wouldn't put the line over it. I would just go like this. So actually, let's get, well, you know what? Here, we'll box off my answer. There we go. And that would be cubic yards, right? So yards cubed. There we go. Alrighty, now you could actually put this into your Y1 and you could look at the picture, or you should just notice from part D that as you plugged in 10, then 11, then 12, then 13, then 14, that the values, the Y values, were decreasing. So in other words then, I know that my C of T is, just generally speaking, going to look like that. And they want to know whether what I got in part D, was that approximation an overestimate or an underestimate? So guys, I think the easiest way to do this question is exactly what I'm doing. Just draw yourself a picture and say like this was 10 and this was 14. Okay, and if we're doing trapezoidal rule, remember we would go up, and then let's say this was 12, we go up, and then we would draw ourselves a trapezoid. And then we would go to, I'm sorry, that was 11, right? I can't count. Then we go up to 12 and we would do it again. And then we go up to 13 and then we do it again. And then we go up to 14 and we do it again. Now, I know it's not significant, but do you see this is a slight overestimate? This one also overestimate. This one here overestimate. So then you would say something to this effect. Okay, so part C's answer was an overestimate because the area of the trapezoids are more than the area under the curve because the trapezoids go above the curve. So in other words, they encompass more area than what's actually under this curve. Make sure that if you get a question like this, that you label this curve so whoever's grading your exam knows what it is that you're talking about. All right, last question. Last question is asking for an amount of dirt. So when it wants an amount, and what you have here, look at what you have here, is a rate, and you want an amount, what should you do? Hopefully you're realizing that you should integrate. So I'm just going to integrate that C of T, and I'm going to integrate from 10 to 14. And you have a calculator, because you are allowed to use a calculator on the AP exam. I would use it in this case. And why don't you put that in, take a second, and see what you get. And there you go. Don't forget to write yards cubed. Don't forget to write your units as well.